this week we are actually going to spend a whole week on something that may seem like it doesn't have very much to do with language because it's mostly math. But it's worth spending a whole week on this to go over some basic concepts, because what we're going to cover is really the basic engine, the basic concepts of how modern AI works. So to recap, what we covered last week was building spell checkers. We started looking at that. And what we saw is that there's a few different ways to correct, or there's three basic steps actually of spelling correctors, which involves correcting. So the first is to detect a spelling error. And we're focusing right now, last week and mostly this week as well, on errors that can be detected by just comparing them to the dictionary. So they create non-word errors. Once you detect an error, then you want to be able to generate spelling candidates, possible corrections. Is this perhaps what you meant to spell? And we look at a rule-based method in edit distance, so guessing by how far, right, how many changes are there to get from this word to one that you might have wanted to spell. And then there's some other techniques like the similarity key technique, which is described briefly in the book. So you generate them, but then you got to rank them, right? Because if you just go by minimum edit distance and just look at words that are only one letter apart, there could be a lot of them. I mean, think about how you started learning to read, right? You were presented with a word and it was cat, C-A-T. And then they started presenting you with these other words that only changed in one letter. Pat, mat, tat, hat, sat, and so on. So just going with a minimum edit distance and ranking them by that may not be good enough. There could be a lot of words that are only one minimum edit distance away. And if you are, like me, consistently misspelling certain words in a certain way, it would be annoying if you always had to scroll down to number 10 to choose the correction. That's always ranked number 10 on those generated spelling candidates. If most people are misspelling in the same way, chances are they're going to want the same spelling candidate to be higher up so they can quickly select it. So a good spell checker will rank the candidates by something more than edit distance, and since edit distance by itself is not enough, we look at probabilistic methods. So this is the AI sausage maker of AI, or this is a sausage maker of AI. Let me restate that. If you think about, well, maybe you haven't heard the saying, but there's a saying that once you see how the sausage is made, you won't want to eat it because you realize it may taste good, but what goes into it is not what you were hoping. And I think this is true for AI, where a lot of people think, oh, it's like the sci-fi movies. It is intelligence. It's artificial intelligence. We're going to end up with CP3O walking around pretty soon. And then they realize, well, actually, it kind of all boils down to probability and statistics, the kind of stuff I learned in high school. Wow, not quite as exciting as I was hoping. But it is indeed the basic fundamentals of how AI works, whether in language technology or in the other areas where we use the same basic engine to build something useful. So that's why we're going to spend a whole week just understanding, and probably a lot of repetition, or it may seem to you, especially if you're already used to it, on these concepts and formula and some application, but we're really going to take a pause from application, and then we'll come back to it next week when we look at grammar checkers, which is really spell checkers where your mistake didn't create a non-word, it just created another word, and how do you figure that out?